Hi students, so in this video we are going to talk about empirical formula and your molecular formula. What is the relation between empirical formula and your molecular formula, and how to do the calculations, how to do the numericals that are based on this topic that we are going to study in this video. And we will also take a question from your text so that you could have more clarification regarding the numerical, because the most important part from this is the calculative part, the numerical part. So let's start with empirical formula. What is empirical formula that we will study first. empirical formula होता क्या है पहले हम यह जानेंगे, ठीक. empirical formula can be defined as the simplest whole number ratio between elements in a compound. किसी भी compound में elements कितने simplest whole number ratio में उसको आप कह देते हो empirical formula. For example देखिए, अगर मैं कहता हूँ C2H6 and O4, सपोज मैंने एक तरह का आपको एग्जाम्पल ये वाला दे दिया. मैंने कहा कि ये किसी पर्टिकुलर कंपाउंड का फॉर्मूला है. जस्ट एन एग्जाम्पल, दिस इज जस्ट एन एग्जाम्पल. सो इन दिस एग्जाम्पल द सिंपलेस्ट होल नंबर रेशियो दैट यू कैन टेक इज बाय डिवाइडिंग इट बाय 2. सो द सिंपलेस्ट दैट यू विल गेट इज CH3O2. यू कैनॉट मेक इट मोर सिंपलर देन दिस. इससे ज़्यादा सिंपल नहीं किया जा सकता. क्लियर. सो द फॉर्मूला दैट यू आर गेटिंग राइट नाउ इज कॉल्ड एज मॉलिक्यूलर इज कॉल्ड एज एम्पेरिकल फॉर्मूला. दिस इज योर empirical formula, and from here what you can conclude about your molecular formula. What is molecular formula? Molecular formula tells you the actual number of atoms present in the molecule of a compound. Okay, the molecular formula tells you the actual number of atoms. I'm talking about actual numbers. Here we are not talking about actual number. In empirical formula we are not talking about actual number, we are just talking about the simplest whole number ratio. This is simple, or we can say simplest whole number ratio. This is simplest whole number ratio. Which one? Empirical formula. But when we are talking about molecular formula, now why I'm calling this as molecular formula? I'm calling this as molecular formula because here you are getting that actually the number of C is 2. In actual you are getting what is the number of carbon. Actual number of hydrogen is 6. Actual number of oxygen is 4. Clear. But in the simplest form what we are getting CH3O2. Again I'm telling you this is just an example. Okay, do not think that what will be the name of this given compound, like that. Do not think like that. That is just an example. Clear. Just an example. So this one tells you simplest whole number ratio, and this is telling you actual number of atoms. So this is the difference between your empirical formula and molecular formula. I hope it is clear. Empirical formula आपको देगा simplest whole number ratio, जबकि molecular formula आपको देता है actual number of elements that are present in the molecule of a compound. So that is the difference between empirical formula and molecular formula, and I hope now you're getting that there is something which is between empirical formula and molecular formula, and that is called as, in your book, that is denoted as N. Okay, if you multiply empirical formula into N, it will give you molecular formula. How? Again, from same example we can see. Take this example again. If I write here as CH3O2, because you know this is empirical formula, this is empirical formula, into, suppose we don't know what is the value of N, leave it, is equal to molecular formula is C2H6O4. Now what number should be placed here? It should be 2. N should be there. Okay, because it will make it C2. 3 2 is 6, 2 2 is 4. It means the value of N here is 2. Okay, so this I have proved by this example only, that there is something N which gives a relation between empirical formula and molecular formula, and that you can calculate by this method. Okay, by this you can calculate the value of N, or they will give you the value of N and they can ask you molecular formula. Suppose they will give you the value of N, they will give you the value of molecular formula, and then they will ask you what should be the empirical formula. Question can come in any way. Okay, but the most important type of numerical that comes in examination, that I will discuss after this. Okay, but question can come in any way. हो सकता है आपको empirical formula दे दिया जाए और आपको molecular formula दिया जाए, पूछा जाए कि N की वैल्यू क्या है, या फिर आपको N और empirical formula की वैल्यू दे दी जाए और आपको molecular formula बनाने को कहा जाए, जो normally नहीं आता है क्योंकि ये easy question है. जो टफ क्वेश्चन है वो हम इसके बाद डिस्कस करने वाले हैं, जो मोस्ट इंपॉर्टेंट पार्ट है इस क्वेश्चन. So let me write that question for you. So here is the question, the detail that I have taken from your textbook. This is a question from your textbook only. So these are the details given, and with the help of these details we are going to find out what is the molecular formula of this particular compound which is having these details. Okay, molecular formula. So first we are going to write the steps. After knowing the steps, we are going to solve this numerical. Okay, first thing what you have to do is write element with their percentage. Write element with percentage, that you have to do. First part is write the element with percentage. Suppose here it's carbon, so carbon 40, hydrogen 6.7, oxygen 53.3, like that you have to write. Okay, try to write in front. Second, the next part is write atomic weight in front of percentage. जहाँ पर अपने परसेंटेज को लिखा है उसके आगे आपने क्या कर देना है, उसके एटॉमिक वेट को लिख देना है, एटॉमिक नंबर को नहीं, एटॉमिक वेट का. राइट द एटॉमिक नंबर, सॉरी एटॉमिक वेट इन फ्रंट ऑफ द परसेंटेज देयर. ओके, थर्ड वन, पिक अप द स्मॉलेस्ट रेशियो आफ्टर dividing percentage by atomic weight. Okay, what you have to do is after writing this percentage and then atomic weight, divide percentage by atomic weight, and then you have to pick up the smallest ratio. Whatever is the smallest ratio there, means whatever the smallest number you are getting there, that you have to pick. Fourth part is divide all obtained ratio by the ratio from step number 3. Okay, from step 3, whatever the smallest ratio you have taken from there, with that ratio you have to divide each and every ratio, which was the answer for the third part. In the third part you are going to get many ratios. Suppose you are getting 2, 3, and you are getting again 2 you are getting. Okay, suppose like this you are getting. So what you have to pick is, you have to pick 2, because 2 is also here, 2 is also here. Suppose you are getting the ratio as 3, 7, and suppose 6 you are getting. Then which one you have to pick? You have to pick 3. This is your step number 3rd. From step number 3rd, according to step number 3rd, the smallest one is 3. Now what you have to do is divide each and every ratio that you have obtained in step 3 by that smallest ratio. Means after this what you are going to do is 3 by 3, because this is the smallest one, 7 by 3, and next 6 by 3. In this way you have to do this question. So let's try it now with the help of the details given. I hope you would have written these steps. Now with the help of these steps I am going to tell you how to solve this question. Now see, first step was carbon, H, oxygen. Write the name of element with their percentage. 40, then 6.7, then 53.3. This was the step number 1. Step number 2 was write their atomic weight. So here it's 12, here it's 1, and here it's 16. Step 2 is over. Okay, now third step, 40 by 12, you have to take the smallest ratio. 6.7 by 1, 53.3 by 16. Okay, so 40 by 12 will become 20 by 6, 10 by 3, it will come out to be 3.33. Okay, it is a non-terminating decimal. After non-terminating it's 3333, so we can write it as 3.33. 6.7 by 1 can be written as 6.7 is equal to 53.3 by 16 will come out to be 3.33. As I have told you, this question I have taken from your text. Okay, so the 53.3 when divided by 16 is giving 3.33. Do not think that how I calculated within seconds. Already I told you this question I have taken from your textbook. Okay, so it is also coming out to be 3.33. Okay, this was easy to calculate, so I showed you how to calculate. This I have taken from your book, 3.33. Now step number 3 is over. Step number 3 said that out of the selected questions, selected answers, which one you have to pick up? You have to pick up this smallest one, but there are two smaller. The quantities that you want, दे आर टू इन नंबर, हेयर ऑल्सो एंड हेयर ऑल्सो. 3.33 3.33 दोनों तरफ आपको क्या दिख रहा है 3.33. सो स्मॉलेस्ट नंबर क्या हो गया, स्मॉलेस्ट नंबर इज 3.33. इन बोथ द केसेस नंबर इज 3.33. सो दिस वन यू हैव टू पिक. Okay, as I told you, you have to pick the smallest one, but both are same, so you have to pick 3.33. Now what was written in step number third? Whatever number you are picking, divide the answers obtained by it. Here also 3.33, here also 3.33. Okay, now see what you are getting. Here you will get 1, here you won't get exact 2, but it is nearly equal to 2, and here you are going to get 1. Okay, here you are going to get 1, here you are going to get 2, here you are going to get 1. I hope it is easy for you. This will get cancelled. This is 2 times, this is 1 time. So now what you have to write is this. What you are going to get right now is called as empirical formula, because this is the simplest whole number ratio. Go back to the definition. Definition says that सिंपलेस्ट होल नंबर रेशियो को ही इंपेरिकल फॉर्मूला कहा जाता है. इसका मतलब जो आपको मिलने वाला है वो है आपका इंपेरिकल फॉर्मूला. कितना आया देखिए, कार्बन कितना है 1, सो CH2OYH2 quantity is 2 there, number is 2 there, CH2, and this is your empirical formula. Now one more formula that you have to remember is molecular weight is equal to twice into vapor density. Another formula, because in the question vapor density is given. Okay, so molecular weight is always equal to twice of vapor density. So it means that I can calculate molecular weight, implies it will be twice into 30 is equal to 60. It may be gram, u, whatever is given there. Suppose we take it as u, unified mass. Okay, so it's 60 u. Okay, now previous part what we did, we wrote a formula. That formula was empirical weight into n is equal to molecular weight. Empirical weight into n equal to molecular weight. So how to calculate n? Okay, so empirical weight we don't know, but we know the formula. So can we calculate empirical weight by the formula? Definitely. So carbon it's 12, hydrogen it's 2, oxygen it's 16. Why hydrogen 2? Because for 1 it's 1 gram, but for 2 it will be 2 gram. So 12 to 14, 14 plus 16 will give you 30. So empirical weight is there, n is not there, molecular weight is there. Okay, so n is equal to molecular weight upon empirical weight. What is the molecular weight here? 60, calculated by using vapor density upon 30 will give you 2. I hope it is clear. Now how to get a molecular formula? Same way, same you have to remember this one. Weight can also, in terms of weight also we can write like this, and in terms of formula also we can write like this. So molecular formula is equal to, see the reverse, molecular formula is equal to n, means 2 into empirical formula is CH2O. So multiply it, you will get C2H4O2. So in this way you are going to calculate molecular formula for any given, whatever the details are given in the question, according to that you have to do. So mostly the question are based on this. If they will give you a shorter question which may be of 1 or 2 marks, definitely they will give you from this part, means formula part, with the help of formula. Suppose they will give you the vapor density of a given compound is 30, what will be its molecular weight, and it may be of 1 mark or 2, not of 2 mark, but mostly it will be of 1 mark, because it is simply a formula based question. So questions are from this part only, but a good question, question carrying good weightage is in this form. In this form mostly you get question from this part, from empirical formula and molecular formula part. You get a question this, and this may be of 4 or 5 marks in your boards or in your class, wherever you are getting these questions. So the weightage of this is 4 to 5 marks. If this question comes, it will definitely have a weightage of 4 to 5 marks. And it is very simple. What you have to do is, see, everything is given to you, the details are given. What you have to do, write the compound name, element name, and write the percentage. Then you have to think of its atomic weight. What is the atomic weight of given element? Then divide it. You will get a fraction. You will get a number. Suppose here you are getting that number is 3.33 by dividing 40 by 12 you are getting 3.33, 6.7 by 1 you are getting 6.7, 53.3 by 16 you are getting 3.33. You will get a number. So pick the smallest one of that. Here what was the scene was, two numbers were there and both were same, and we have to consider both. So what we took, 3.33. So 3.33 by 3.33 give you 1, here it give you 2, here it give you 1. So since you are getting the ratio, remember that in the previous part when we started this video, I told you that empirical formula is the simplest whole number ratio of elements. Okay, so since you are getting a simplest ratio, so definitely what you are going to get is empirical formula, not molecular formula. Okay, now molecular weight can be calculated with the help of vapor density. How? The double of vapor density is molecular weight, that you have to remember. Okay, so twice into 30 is giving you 60 U. Okay, 60 gram mole. Here it's U means unified mass. Earlier we used to use AMU, atomic mass unit. Somewhere we use gram, and mostly now we use U. U means unified mass. Okay, so with the help of this formula, weight can be written as formula. In the second part, same formula you have to write, but what you have to do is, instead of weight you have to write formula only. That much is the difference here. So empirical weight equal into N equal to molecular weight. Now N equals to C. This is in multiplication, so this will go in division. So molecular weight upon empirical weight. 60 by 30 empirical weight we calculated here. Okay, so the answer we got was 2. So again the same formula, but weight will be changed to formula. So empirical formula into N equal to molecular formula, but we want molecular formula. So what we will do, we will write molecular formula is equal to N into empirical formula. Empirical formula was CH2O and the value of N we got was 2. So C2H4O2 is the molecular formula of the given compound. So I hope now it is clear to you that what is empirical formula and how it is different from molecular formula. Empirical formula, simplest whole number ratio, and your molecular formula means what is the actual number of atoms present in the molecule of a compound. In that particular molecule, how many atoms are there present actually. Actually means even if we are getting simplest whole number ratio, we are not going to take it as it here, as C it here, C2H4O2. Here also you can divide it by 2 and make it CH2O. But we are not making it because we are writing molecular formula. We want actual number. But if we are writing molecular formula, then what we have to take? We have to take the simplest whole number ratio. So try to remember it like this: empirical formula, simplest whole number ratio; molecular formula, actual number of atoms. In that way you can remember, and for the mathematical calculation you can take this as an example. If still there is any question, you can post your question in the comment section and I will give answer for that. Okay, so I hope this part will be clear to you, and if it is not clear, still consult your textbook, consult your teacher for more clearance. So till then, keep growing, keep studying. Thank you.